Come all of you, let us look at Kjeldhal's method to estimate nitrogen in organic compounds. And let us suppose that you take W grams of organic compound and you are going to find out the percentage of nitrogen it has, wherein you convert the nitrogen into ammonium sulfate by digesting the given organic compound with a concentrated sulfuric acid. Notice that this particular method cannot be used to find the percentage of nitrogen in compounds where nitrogen is a part of ring like pyridine, pyrrole, quinoline. It can also be not used for nitrobenzene where there is a nitro group, nitrogen is there in nitro group, or in azo compounds like azobenzene where there is N double bond N. Because in these cases the nitrogen of organic compound would not quantitatively become ammonium sulfate even if you try. A part of it will be wasted as N2 gas. So for these compounds like pyridine, quinoline, pyrrole, nitrobenzene and azobenzene, you cannot use Kjeldhal method. Here the organic compound, when it is digested with concentrated sulfuric acid in presence of a little copper sulfate catalyst, is converted into ammonium sulfate. Notice you will also add a small amount of K2SO4 for the process because K2SO4 will increase the boiling point of sulfuric acid so that the entire nitrogen of organic compound would become ammonium sulfate. Once you get that white mass of ammonium sulfate after complete digestion, the ammonium sulfate solution is treated with either NaOH or KOH so that entire ammonium sulfate becomes ammonia gas. You are adding NaOH or KOH in excess to the original solution so that all the nitrogen of the organic compound will be converted to ammonia. And the ammonia is now bubbled into a conical flask that has excess of acid. You can take sulfuric acid for that matter. Excess of acid. The normality of the acid you have taken, let us say, is N-A and its volume is V-A. This is excess. When you take excess of acid, a part of the acid is actually neutralized by ammonia. When once a part of the acid is neutralized, remaining acid is left. How much acid is left? You can find out by titrating this acid left out with a standard alkali like NaOH or KOH. Suppose this process which we call back titration, wherein you estimate the amount of acid left out because you have taken excess. The amount of acid left out is equivalent to NBVB, that is the normality of the base, standard base used in the titration and the volume of the base you used in the titration. So actually the Na-Va- minus NBVB, that is the original amount of the excess of acid which you have taken in terms of normality. Na- is the normality of the original acid you have taken in excess, and Va- is the volume of the acid you have taken in excess, out of which whatever is left out is neutralized by this NBVB. So Na-Va- minus NBVB corresponds to NaVa of the original acid that has been neutralized, which is equal to the equivalence to the ammonia that got liberated. Now sir, ammonia molecular weight is equal to 14 plus 3 into 117. It means there are 14 milligrams of nitrogen in every 1 milliequivalence of ammonia. And now the milliequivalence of ammonia that got liberated in the process is equal to NaVa. That is the acid used up in the back, left out in back titration. This divided by the weight of organic compound you have taken. Now the milligrams can be converted into grams by dividing with 1000. Now these many grams of nitrogen is there. Out of W grams of organic compound, 100 grams contain how much? Will give you the percentage of nitrogen. This on simplification will become 1.4 NaVa by W. If you don't know the normality of the acid, but if you know molarity of the acid, then molarity of acid into the basicity of acid will give you the normality. So 1.4 into molarity of the acid used in back titration and basicity of the acid used in back titration into volume of the acid used in back titration divided by W will give you the percentage. You know, basicity of sulfuric acid H2SO4 is 2, HCl is 1, HNO3 is 1, so on. Now let us look at this process diagrammatically. If you can look at a very brief, here this is a Kjeldhal flask where you have taken W grams of organic compound and concentrated sulfuric acid. A little amount of copper sulfate is added as a catalyst, that's why it got blue color. Now it is digested for 6-7 hours. All the nitrogen organic compound became ammonia. When here it became ammonia, you are adding NaOH or KOH to liberate ammonia. The ammonia gets liberated and passes through Kjeldhal trap. Through this condenser it gets cooled and collected here into a conical flask that has known volume of standard acid. This is taken in excess. Now you take it out, how much acid is left out, you titrate with the help of a base, NBVB, and you know all other calculation, right? So this is called Kjeldhal estimation to find the percentage of nitrogen. Again the formula, percentage of nitrogen is equal to 1.4 into NaVA, normality of the acid, and the volume of acid used in back titration divided by W, or percentage of nitrogen is equal to 1.4 into molarity of the acid used in back titration into volume of the acid used in back titration into basicity of the acid divided by W of organic compound. Thank you.